and it should. Whoa, there he is. Hey, everybody. Welcome to a TruTech Christmas Special. Merry Christmas, everyone. Happy New Year coming up. Tyler Nelson with me tonight. Mr. Nelson, how are you, sir?
If I was any better, it would simply be unfair because I'm with you, Eric. So we're doing okay. I am donning my Jets cap here, my Santa cap, and you can't see it, but there is the Oh Fudge shirt from A Christmas Story.
All
And
right.
like any good live stream should be, there's going to be strippers, and it's going to be me. So hold on one second, but I promise we won't get banned from this because you'll see the point in a second. So hang tight.
Here we go. He's got layers here. It's like an onion. We're peeling back the layers of Tyler Nelson right here. All right. So, now, okay. All right. We got the full Jets gear going on here tonight, huh?
So now there's two schools of thought now. So I know some of the people that are going to be watching this are going to say, with me wearing the Jets thing, oh, bless his heart, because they're going to, feel bad for me. And then there's going to be the very few Jet fans out there that are actually going to say, born in sin, come on in. Now, I don't know if either one of those sit very comfortably with me, but I'll take anyone that I could get at this stage. So, so here we are. And
you're sitting here with me, who's a not really a football or sports fan. So I'm just like, who's the Jets?
Which is great. Right. Exactly. Who are the Jets? Who's this quarterback they had that does ayahuasca? Who is that? So
cool you
anyway.
Jets. Cool you Jets.
Right. Exactly. So here we are in this faded day together, talking about one of our favorite subjects, and Combustion passed presently and where it sits, and then the future. So I know that you must have something cooking from the past. So I'm going to kind
We
of let
got
you
we
steer
got
the
some
boat with this.
we got some old stuff going on here that I'm going to show, but let's introduce you a little bit. I think maybe the audience probably knows me a little bit here, but let's introduce you because you do a lot of combustion training in your
Mhm.
present position and
Yeah.
travel a lot and all kinds of neat stuff. So let's learn a little bit about Tyler first.
Thank you very much. So, again, Tyler Nelson, I am the instrumentation sales manager and business development manager for Sauermann Americas. I predominantly right now do a lot with combustion and training, and whether it's classroom or live fire, and then eventually on the refrigeration side coming up here in the next few months. I was a former contractor for 20 plus years, proudly hold the designation of Master HVACR, so I'm very proud of that and proud of what I try to do for the industry and try to educate and enjoy doing what I do and enjoy helping the industry out and paying it forward. There was a lot of generosity given to me over the years and a lot of kindness provided to me over the years. And it's just my a privilege for me to work alongside people like yourselves, Eric, and the team at TruTech Tools and everybody else out in the industry, and just trying to pay it forward and educate and do it with kindness and proper motive.
Very nice. Very nice. So you spend a lot of time on the road. I see you traveling all over the
Yeah.
place. So you're coast to coast and getting to visit with everybody. And Tyler does a good training class. So if he's in your neighborhood, you get a chance to go see him,
Thank
stop
you.
in, learn a little bit.
Yeah,
And
coast to coast and soon to be a global spin on it too, from what I gather. So we'll see how that all shakes out. And yeah, I'm on the road quite a bit, and I'm still married. So as of the moment, so we're doing okay. Just kidding, just kidding. She hasn't killed me yet, but I'm sure she's trying. I just don't know it, but she's probably fine by me.
I came home one night and found my wife watching a TV show called The Poisoner's Handbook, and I'm like, "What's that all about, honey?" She says, "Well, they talk about a lot of ways to kill people and how they figured them all out." And I'm like, "Oh, this is not a good sign."
Nope. Better
Hey,
fly right.
I'm still here, so nothing's happened yet.
Yeah. My wife teases me. She goes, "Remember, I cook your food. You might want to smell it first before you eat it." I'm just giving you a hint. I'm like, "Okay, I got you. I got you."
Hey, but anyways, enough of that. Let's talk about past combustion
Yes.
first. We're gonna go with past. And
Mhm.
I did a little bit of research and I'd heard of this device in passing in my years. And I've been doing combustion testing 20 years now. I started out in a little tiny residential shop in Southern Illinois. And the first class I had to go to was NCI. And I've told this story a lot. I had to go watch Jim Davis throw combustion analyzers across a classroom for 3 days. Wasn't allowed to touch a combustion appliance until I took that class and passed the test.
That's great.
That was having not been in the industry, but then been in the industry for all these years now. It was an eye opener to me how other people do things because of how I was taught to do that. So, um,
Sure.
I'll say I've been around combustion a lot, but it still surprises me to this day how many people don't use combustion analyzers because of how useful they are. Um,
Yeah.
to me, they're like any other meter. But let's go back and look at past combustion analyzers. And you guys out in the chat, I want you to throw some numbers in here. All right. So we're going to look at this. This device is called an ORSAT analyzer or an ORSAT device. And you can see this was a drawing from Vogel in 1972, but this device is considerably older than that. And it was actually patented. So I'm going to give a couple seconds here. Throw in the chat what year you think this device was patented. No fair looking it up on the internet. But like this device, combustion analysis has been around way, way longer even than I realized. And we were talking right before the show, and I showed you the date. So you're kind of cheating here.
Yeah.
I think it was around longer than you realized too.
Oh yeah. It looks like, honestly, it looks like something you would do in antiquated times for a blood transfusion. is really what it looks like, not for combustion. So, or for some kind of bloodletting. But yeah, it's been around for quite a bit. So I don't want to steal your thunder. So why don't you? We're getting a lower numbers there. You still got to go lower
Yeah,
there, my
you
friend.
got to go a
So
little bit lower, guys. But
yeah,
I mean,
yeah.
we'll just talk about this for a second. Like the flue gas enters there at E and comes up and goes through the vials there to get different samples to test different components of the gas. Like it was a really neat device. I did some reading about it. It can test CO2, CO2. I think it was also SO, I think it could test for based on what chemicals and what reactants you put in here. But
Mhm.
it was
Yeah.
really interesting to learn about this. So, if you guys want to go read about it online. But anyways, we got 1946, 1935, AD. Yeah. It was definitely AD.
You're getting there. We got to go
So
a little north of that.
this held British patent number 1853, was issued on 5 May of 1873, which means we've been doing combustion testing. Like it's been a thing for more than 150 years.
Yeah, so it's held relevancy back then, and just look at the things they would have been testing on, and but yet in today's present affairs, we can barely get people to use one. It's amazing how this was developed back then in such a long time ago. But it shows that very intelligent minds were at play back then, and it's still being used today. You still see, if you go on YouTube, you'll still see classes on it or people giving instructions on how to use one and everything else with it.
Well, and I think it's used more in scientific settings still
Yeah,
today,
sure.
because you
Hmm.
can manipulate things a little bit more with adding different reactants and things like
Hmm.
that in the bottles. But to me, it was really interesting. This was actually invented to test the combustion of kilns in the
Hmm.
day when it was started, and that's why it was made so that they could test those kilns. Um, but holy cow, that's a that's been around a while, and we
Yeah.
moved on from this things like this to slightly more service friendly devices, right? Things like
Hmm.
the wet kit,
Yeah.
known as a Firite bottle in a lot of cases, or a shaker
Hmm.
bottle.
Hmm.
Um,
Fire Right Classic, I think they call it, right?
yeah, and I just found out that this tool has actually been recently discontinued, which is probably going to disappoint some people.
Yeah.
But I got to say, I think this one had outlived its days. It was a
Yeah.
good tool in the day. It was better than nothing.
Yeah, and going back to that ore set, dipping back to that for a second, one of the things they try to do with that with the kilns is to make sure that they had proper burn rates and proper firing of those things because they needed as much longevity from the way that operated as possible. So they were even ahead of their time back then, and the way that we apply combustion analysis today to as longevity of a piece of equipment as being one of the predictors of how a system's operating.
Well, and they probably also needed to control it when they were firing various things in those kilns. They needed to be able to
Hmm.
control that and some of the chemicals that were going through there, because a lot of those kilns, there wasn't really a heat exchanger. It was just it was a direct fire on there. And depending on how they controlled that would change the way some of the things were um, the objects, the whatever they were making, bowls, pottery, whatever it was
Hmm.
in those kilns, or steel or anything else.
Hmm.
So pretty neat. But yeah,
Yeah.
so these were used for a lot of years.
Hmm.
They could tell you information, but the challenge really looking back on them was they could only give us a snapshot. It was a one-time snapshot, and we've progressed forward. The digital combustion analyzers, or electronic combustion analyzers, came out in the late 70s, I think.
Yeah. Yep.
So they were brought out, they're before I was born,
Hmm.
and they've progressed over the years. There's been a lot of progression in those. Shoot, the ones that the early ones were literally a huge suitcase that got carried around and had all kinds of neat stuff on them. So, like, that's a little bit of the history of combustion analysis. And we've moved into a lot smaller devices, a lot more compact devices, things that are easily carried in a hand or a tool bag or into a house now, or into a business, up on a roof.
Something, just tinier, just smaller. I should say tinier, but smaller. And one of the things we've learned in, at least in present day, and in dipping even farther back, is we have learned through testing through the 3 different phases: light off, steady state, and shutdown, that there are behavioral characteristics with a piece of equipment that will manifest themselves at each one of those 3 phases. Some carry over, but like burner alignment issues and things like that from light off to steady state. But there are unique sets of characteristics. So we are now, as a result of using one of these, able to dial in or hone in our diagnostic approach that much better, because by using one, we've learned these characteristics over time, and it's been an integral tool. We love talking about this now, and Eric, we talked about this on the phone. This isn't just a job for us; it's also a hobby to a greater degree, because we're interested in this. We dig it, and we're not ashamed to say it, because it is cool. And 2 of the reasons I think people like this, and we were talking about this on the phone as well, is 1, it provides analytics. Everybody loves analytics. So there's a lot of people that wear smartwatches that monitor your steps, your calories, and everything else, and dictate how much beer you can drink and how many cookies you can eat at the holidays, all kidding aside. But you have those analytics, whether it's your investment performance or how many likes you get on a post, whatever. But the other thing it does is we all seem to gravitate towards some form of instant gratification, some more than others, but everybody likes instant gratification. Well, with a combustion analyzer, when you're adjusting a system, you get to fully enjoy instant gratification, because you see the results of your adjustments in real time. You don't have to wait. Like, for example, if you had an issue with your cholesterol and you went to your doctor, it could take 6 months for the results to come back if the protocol they put you on is working. Combustion doesn't work that way. Combustion says, like Veruca, I want it now from Willy Wonka. You want the results, you get it now. You make an adjustment, you see it now. And that's 2 of the reasons why people really like this. It's like they don't know why, and they're ashamed to say it or ashamed to reconcile it. But it does cater to those two things. So it's almost like a diagnostic or commissioning video game in a sense when you operate one, and it has a lot of touch points to it when people utilize one.
Yeah, and now we'll kind of transition into where we are present day with this. In the past, the more recent past, we used analyzers, and we used a lot of thermal printers. Like we would print off the results of an analysis. But even so, that printout really only showed us a very narrow snapshot. Like it was an instant in time. And you talked about monitoring that thing over the complete cycle of operations, startup, running, and shutdown. And just taking that one little tiny snapshot and saying, yep, this thing was running good at that point in time, or within specs. It was the best we had at the time. It was better than nothing. But I can see where it's not as good as what we have today, what we have available today with graphing and long-term data logging and recording. Really allows us to go new places, and that's kind of where we're at today. Right.
Even when it comes to cracked heat exchanger verification, say for example on a forced air system, if you're not seeing that O2 spike when the blower comes on, you're also still able to let that system run and get it to steady state, because if it doesn't manifest itself in light off, the challenge is going to happen 5 minutes into the operation time at steady state, where those symptoms can show themselves with excessive amounts of CO, or putting it into the, and it's spilling into the supply trunk, or being sucked in through a return, depending on how the system is operating. But by letting it run and going and having that data logging capability and having a continuous monitoring of the combustion process, you're able to look at those different characteristic periods or operational periods and extract those characteristics out, and then come up with a proper diagnosis. And it just makes you a more thorough technician. So in present day, it holds a very, very valid place. You know, when we first started doing this, it was to verify CO and even back with the white kit CO2, but CO and a little bit of oxygen, and that was it. But more of CO, more of the danger factor. But now it's come into much more of a sweet spot where you're able to dial in the efficiency of a system, albeit the fuel utilization of it, but you're able to dial that in much more accurately. And you're also able to ascertain if you have too much excess air in the system by looking at the oxygen. You're able to use it from that perspective. So from a commissioning standpoint, it holds a very valid place if you're an installer, because the equipment you're getting in, chances are, is not the way that you think it's set up. But you don't know this because you're not testing. I've been to a lot of factories, and a lot of the engineers, to a man or a woman, have said, we're sending you stuff under fired because we don't want the liability. Now, I just did training recently up in Goshen, New York, for a very prominent contractor in this country, one of the largest. And this was their house system. When we were dialing it in, it was significantly overfired from the factory. So we had to dial the gas pressure back and correct some of the errors in it, and then hit it within that sweet spot. And now it's functional. But with an analyzer, we're able to see that. But without it, they were flying blind. They did not know that until we actually put that into practical application. And I'm sure, Eric, you've seen that in the evolution of your career in doing this, and I'm sure many, many times.
Oh, some of the things that I've found with it really kind of surprised me looking back on it now and thinking about some of the things. I didn't think a lot about it at the time because it was just, that's what I'm doing. This is what I'm doing every day. And since I didn't have that transition from not testing into testing, I didn't have a part of my career where I wasn't testing something. It was just normal to me. But
Right.
to look back on it and think about it now, yeah, there was some really, really interesting things to be found in there.
Right.
And to be able to see these things and visualize these things, when I look back now, to me, it's no different than carrying an electrical meter onto a job,
Yeah.
carrying getting pressure and temperature to do refrigerant charging. Like, that's just part of what we're supposed to do.
Yeah. Imagine if you couldn't walk away from a fuel-fired appliance and know it was running unless you use an analyzer. You know, you're using a gauge set and your probes, your thermistors, your thermocouples, and everything else to do your superheat and your subcooling. Imagine if you could not walk away from that fuel-fired appliance. You know, combustion testing would not be the red-headed stepchild of the HVAC field like it's been. You know, it's becoming, we have to admit though, Eric, at least from my perspective, it's becoming more and more in vogue than it was before. And in vogue, not from a passing fad, in vogue because there has been a significant education. Like I'm looking at the chat right now and I see Donald Baker on here. I know who he is. You know, so I met him when I was at the CMPX. You know, I know who he is. He follows my stuff. He's an educated tech, and I'm just isolating one person in here. He's a highly educated tech. There's this better HVAC movement. You know it because Bill's been a part of it. That is trying to have everybody raise their level. What do they say? A rising tide raises all boats, and that's what we're trying to do here. And it is, you know, very, very, you know, it's very important what we're doing. But we're not alone now. We, as David Richardson from NCI calls it, we're not the crazy person in the park talking to the pigeons about this. Now it's becoming more mainstream, you know. And as I mentioned that too, you got to remember, you talked about Jim Davis. Jim Davis is one of the OGs. You know, Jim Bergman, to me, one of the OGs of this whole thing. And the way that NCI trains, taking Jim out of that equation for a second because he doesn't work for NCI, but the way that the National Comfort Institute trains thoroughly. You want to get educated on this? Go see them. You know, I have my trainings out there. There's other very good manufacturers that have very good trainers out there. But the comprehensive, the extremely comprehensive approach is the paid training that an NCI will do. And if you don't know who they are, you should look them up. The National Comfort Institute. And I think your world will change when you get exposed to what they do, because it's not just combustion. They offer things on many different peripheries.
Yeah, I have to agree with you on that. When I started out, the company that I was with was they were fully invested at NCI, and we did a lot of really neat stuff with that knowledge, and we're able to do things that, you know, quite frankly, a lot of the other contractors in the area couldn't do because we'd gone and gotten that knowledge. But and I guess where we're at now has kind of been a lot of incremental improvements over the past 15 to 20 years with the electronic analyzers. I've seen a lot of improvement in sensors and sensor life, realistically, in the analyzers. Just improvement in the way they're displaying information. Talked about the graphing, I mentioned that, and we talked about that. Like that to me was a huge change, and a huge jump ahead in being able to record what I saw and verify what I saw.
You know what it does too is it enables us now. When we were in school, when everybody's been to school, you're always encouraged to whoever was teaching you to show, especially in math, show your work. Don't just give me the answer to that math problem. You need to show me your work. What Combustion allows us to do is to show our work at every turn. So there's no bait and switch in what we do. We can actually show our work with a combustion analyzer. So you can actually go through your series of readings on a report, and you can actually prove to a customer, listen, you need to replace your inducer. Here is why. It is out of range. And if I can take the liberty and I can actually Google for you what the range of your furnace should be for draft. And it's out of spec. And here is the proof. And this is why you need to replace it. Or if your pressure switch is bad, could you diagnose a bad pressure switch with one? If you're having an issue with that. So it does a bunch of different things, but in the readings, you're showing your work. So you're actually proving, you're not just telling them, you're actually showing them what's going on. So you're not only knowing it for yourself, but you're also educating your customer as to what's going on as well.
Well, and you're also building a data trail for yourself, because if something ever goes wrong, and this is worst case scenario, but one worst case scenario can screw up an entire company, an entire career, a lot of things.
Right.
Yeah. You don't have your ducks in a row and be prepared for that worst case scenario.
Right.
And I've had that thought where other people came behind me and I would say, hey, this thing isn't safe to run. And I've seen other people come behind me that didn't do the testing, and they said, okay, it looks fine to me. Just, we'll go ahead and turn it on and run it. And I had a lot of internal struggle with that at the time.
Oh, yeah.
And what I came to decide was that I had to live with my knowledge, and I had to go home and live with myself, and I had to get up and look at myself in the mirror every morning. And I knew what I had done was kept people safe, as safe as I could.
Yeah.
Now at the time, like, we didn't have that data logging. I could print something out and show that there was a problem right there, but that was a little bit more challenging to show. But creating a data trail of what you've done, and then being able to support that later on, say, if somebody ever questions you, is invaluable. Like, that is a huge differentiator.
Yep. I like when I'm on video with this, as a matter of fact, we were lucky enough today, our video that we have out for Sauermann, which is on Craig Migliaccio's site, AC Service Site. We just hit 30,000 views today, as a matter of fact. So it's like a momentous day for us with the organization. And I've been recorded, in perpetuity for saying this. I liken it to getting your blood work done. You can look good for outward appearances, and you can have great inflection in your voice, but there could be a storm brewing inside of you, and you could have cancer. You could have precursors to a stroke, high cholesterol. You are what your health is what your blood work says it is, despite outward appearances. And it shows the state of your health the day that you're at your doctor's office. Combustion is the exact same thing. It shows the state of health of the piece of the equipment the way that you left it, because people will do things at a property after you leave. Electricians will cut things. We had a roofer one time cut our flue terminations out because he didn't like the aesthetics of the roof, invented the flue properties, everybody, into the attic, because that makes wonderful sense. That's how we kill people. Thank God the inspectors saw it, but we had also proof of our combustion, so luckily nothing ever happened. But the combustion analysis is a snapshot in time. You're dialing things in based on the gas pressure, everything else, the day that you were there. If something happens after you leave, as long as you have that proof, that's your sign of approval. And these things are date stamped. And what I encourage every technician to do, and if you don't do this, I strongly suggest that you do, always email a copy of your test to yourself. Have a combustion file. So if something ever happens after the fact and you ever have to get pursued legally and your organization doesn't have a copy of it, you can then bring that copy that you have to the proceedings and prove the way that you left that piece of equipment in the state of health. It can't be disputed.
That's great advice. And the thing I would add to that is make sure you keep a copy of your in that same file, like where you're keeping all that. Keep a copy of all of your certification
Certs.
Yeah, your calibration certifications. And on your invoice, note the serial number of the analyzer you're using.
Yep. And with our reporting, and I'm sure it does with MeasureQuick too, because we're also on MeasureQuick, but in our combustion report actually gives the model and serial number of the item that's being used. And it just so everybody knows too, with as a manufacturer, we're not trying to be in your pockets with the calibration, getting it in for calibration. Here's the deal. Whether you want to hear this or not, it's the truth. You have to eat your own dog food. What does that mean? You have to take your own advice. You want your customers to call you spring and fall for preventative maintenance, right? Because that's the lifeblood of what you do. You're able to monitor cash flow that way. Well, guess what? You have to take your own counsel and send in your nice little electric toy that's a handheld computer that keeps you safe, keeps you out of liability, and makes you money. You got to send it in once per year, if possible, to get it calibrated, because that calibration certificate lasts for a year. And we don't just calibrate it. And it's not just us, it's the others out there. We don't just calibrate it. We do a full service on it. We quasi rip it apart to make sure everything is functioning for you. For the water trap to the hose, everything else under the sun. Then we calibrate it, and then we kick it back to you. And manufacturers pay a very, very steep fee for the insurance policy for their NIST traceable labs to make sure that there are no issues. Okay, so it's a very important service. Again, in case no one's ever told you, that's what we do. We don't want to be in your pockets because we know it's a nuisance, because we're all contractors, especially Eric and myself. We don't want to be in your pockets, but it's a necessary evil, so to speak, of getting something done, and you got to get the maintenance done on it. Just makes it better for you, much better.
Yeah. And to that point, at that point it's a legal liability thing, because if you get called into court, the first question that they're going to ask, or even on a legal proceeding, I wouldn't say even in court, but the first thing they're going to ask is, where's your calibration certificates, and was it in calibration when you did the testing?
Yeah, exactly.
And you're going to have to go back and prove that.
Yep, 100%. And Eric had mentioned, very important, keep those old certificates, because you're going to need them. What I recommend people do is when you have your analyzer, make a photocopy of the certificate that's in there and just put it into a file. So if by happenstance, when you send it back in for calibration, the manufacturer might just simply discard the old certificate because it's no longer valid and put a new one in there. But you want the proof, because you could have done something 18 months ago that was on the old certificate, and you want to have proof that you actually had it calibrated at that time.
So you're showing your age there when you say photocopy. All right. So, we got these new things now.
Scan or take a picture. Yes.
We can scan it. So if you guys aren't aware, like these new devices have this thing called a scanner in them, and they will make a PDF, and then you can just drop it into a file folder in your file organization system on the cloud, and it's all backed up.
Yes.
It's a really in the wherever the cloud is. I don't know where the cloud is, but it's up there somewhere. But
same place where the drones are flying over New Jersey right now, which everybody's talked about. So it's up in the cloud with the drones.
Well, you guys have got drone problems out there, but we won't drone on about that.
No, it's not. So one of the other things I think too is, now that not only is there combustion done for HVAC, but just so everybody knows, it's done from an emission standpoint I just want to dip into the industrial side for a second. With the now regenerating of the fracking side of things that's going to start taking place here shortly, and this is not a political statement. I'm not concerned with how everybody sits politically. It's just something that's going to start to happen. And one of the things that's going to ramp up now for those that are in this space is the need for, or the continued or increased need for analyzers for the industrial space. Because when combustion or emissions analysis is done on that side of things, everybody, you're looking at different things. You're looking at an emissions profile. And that emissions profile, by doing a combustion test, is a proactive approach to show or to enhance the longevity of the different parts and catalysts on that piece of equipment. So you could tell the amount of CO, how long a carburetor will last on certain pieces of equipment. So the characteristics that you're going to see on an emissions profile will dictate the longevity of that equipment. So even though we're not doing it that way in HVAC, there are parallels to those two different worlds. So for those that maybe have their toe dipped in or their foot dipped into the industrial space, you should see a ramp up eventually here in that. And I've worked in oil fields and those kinds of things and tested in those environments, and it's a whole different animal, and it's very unique, and it carries a whole different set of skills to it, and it's important. So just something I just wanted to make note of for anybody that's watching this that might be involved in industrial. I just wanted to kind of pay credence to that, because you're definitely sitting at the adult table on the combustion world by doing emissions analysis. So it's important stuff.
Yeah, and there's a lot more, I think, attention being given to combustion today with the advent of a lot of the modulating equipment we have. It's on the HVAC side. In the plumbing world, we got all these water heaters now, the modulating gas water heaters, things like that are really demanding. Like in their manuals, they're saying you have to use a combustion analyzer to set this piece of equipment up. And I think that, that's probably driving some interest in this as well. You want to answer a couple questions? We got a couple questions in here.
I saw one that said, I'm reading the bottom, at least I'm at the bottom. It says American Temperature Control.
I'm going to show this one up on the screen here.
Sure.
And he's talking about, and I figure since we got you here from Sauermann, he's talking about Sauermann. He's talking about the heat exchanger integrity test on there.
How much of a difference is a problem? Okay, so the heat exchanger integrity test in our analyzer is going to give you, and when I teach it in class and when I'm on video teaching it, I teach it no matter what analyzer that you're using. So irregardless of that, what you're looking for are the deltas for O2 and CO. Most specifically, when the fan comes on, you are looking for a change from your stabilized oxygen, an increase of 2% or greater as a benchmark. Now, we don't have the liberty of time tonight for me to go through the entire what's called the AHRI Guideline X 2023 statute on correct heat exchanger verification, which I can do offline or I can do via phone call with you. But you're looking for that 2% increase in oxygen.
Like, you can download that for free. You can look.
Correct. Yes. So
again,
yeah, I guess the long answer to the very short question is you're looking for a 2% uptick in oxygen. Now, just because since we kind of open Pandora's box here, if you don't see it there, one of the things I instruct on is letting things get into steady state, because you will see, and I've seen this before, if it didn't misbehave at light off for whatever wacky reason or mechanical reason, not wacky, you might see the high levels of CO, because now you're looking at high levels of CO at that point, manifest themselves at steady state. So typically, for a condensing system at light off, you're looking at under 1,000 ppm at light off only for 60 seconds of burner operation from a functionality standpoint. For a natural draft system, you're looking at under 400 ppm. After you hit those thresholds, then there's a high probability of a correct heat exchanger. When you get into steady state, the general parameters are 100 ppm or less in the stack is what we consider to be acceptable. Obviously, we want it as low as possible. I'm not talking about high fire, but 200 ppm or greater in the stack is a potential red tag situation. And having just mentioned that, you need to have within your companies what your red tag protocol is. Don't just start red tagging things. Obviously, you want to follow a certain level of safety and everything else, but you don't want to violate your company's principles and get somebody jammed up legally. So please have a red tag protocol if you don't already have one. I can help you design one. I've done it well over 100 times now in the last few years. Eric can help you design one too if need be, I'm sure. But we can assist with that. But yeah, those are the general guidelines. And 400 ppm at steady state is an advice to lockout, which means I don't care if your father's a ninja and your sister's a samurai and your mother's a lawyer, we're going to probably shut your system down. Obviously go through the proper protocols to do that, but we're going to shut your system down because it's someone's the chance of death or the chance of injury is high, and death is a potential there as well.
Well, and that's a CO air free number at 400.
Correct. Yes.
Right. That's not just
Absolutely.
your straight up CO reading. That's CO air free, which is always going to be higher than your straight up CO reading.
You want to, just because we're both nerds by design, would you like to explain the difference so that the audience knows, in case people don't know? Math. I'd like to have you just hit that, please.
Math. Oh,
yeah. No, don't just do that. Show your work. We just talked about showing your work. What's wrong with you?
I don't have that work in front of me. But anyway, there's a mathematical equation that does a calculation, and the what CO air free is it's removing the air or the oxygen from that calculation, so it's equalizing the CO across multiple states, and that's why we do the CO air free, and that's why the CO air free is the legal guideline for. I think that's is that an ANSI or a
yes.
Yeah, that's an ANSI document.
Yeah. Yep.
Or is that the UL document?
I think it's ANSI.
I think it's a UL document.
Is it?
Yeah. Yeah. I should know that off the top of my head, but I don't. We should probably both know that.
Yeah.
But either way, 400 parts per million, there's a whole bunch of stuff. And if you really want to read all of there are different limits for different appliances. And there is a complete list of them in the BPI 1200 standard. It's in that document. That's a great resource to go get that. Again, that's a document. Google it, BPI 1200, and then you can go.
Thank you, Casey.
View that. Yep, there's Casey Contreras, good NCI instructor. Thanks, Casey.
There you go.
Yeah, document. Yep, he's got the answer right there. Somebody's
Casey is very much top shelf. So he's telling you it's so.
Yeah, top-notch instructor right there. Yeah.
Oh boy, is he ever. Yes. One of the things that came up, I just saw it earlier from American something.
Yeah, we'll pop that up. American Temperature Control. That is Doug. Yeah, hi Doug. I think.
So the false positive, one of the things that can happen is that if you're using a combustion analyzer that is antiquated or of just a different natures from a quality investment standpoint, let's put it that way. If your CO sensor does not have a NOx filter on it, you can get an inflated carbon monoxide reading. So it plays into it. So what a NOx filter does is it filters out the crosstalk that NOx can create. So for example, if I'm reading, say, 60 ppm of CO with an analyzer without a NOx filter on it, that actual ppm level could be, and this is just an average, between 30 and 37. So it can make the difference. It can make the difference between you shutting something down prematurely versus not. So strongly recommend, and there are many manufacturers, not just us, many manufacturers that make analyzers with NOx filtration on their CO sensor. That is a very important piece of kit to have in your arsenal, is to have it that way.
Yeah, and if you do have an older analyzer that's still running, you're still maintaining it, doesn't have a NOx filter on it, we do have NOx filters available they're an inline filter that'll drop in the hose that are low enough resistance that the pumps will still pull through them. So I think there might be one or two analyzers still produced out there today that don't have NOx filters on them, but that's where like the BPI 1200 protocol, if you're following under that, they require a NOx filtration on that to make sure that the readings are all fairly even there.
Right. Now, Eric, as we kind of we're hitting with like 15 minutes left here, 17 minutes left, whatever it is. So what about where we're heading here future wise?
Let's talk about that. We've got some other questions coming in, but we'll try to get to those at the end. But let's talk about the future. I like that. Where are we headed, Tyler? Because you probably have a better view on this, honestly, than I do. But
I have a couple thoughts. So, and I've been on podcasts, whether it's Brian Orr's or Craig's podcast, talking about this. So two of the things I think that are going to happen, and this is as we go greener. Just so I think most people know this, but if not, one of the most efficacious things to our atmosphere is the production of NOx. And you don't know how much you're producing when you're with a fuel fired appliance, because typically your analyzer you don't have a NOx sensor in it, because you don't need to account for it right now. Yes.
Let me ask you a question here. What is NOx?
NOx is nitric oxide. It is an acidic, poisonous gas. It eats whatever it touches. So it's as if I was taking my cup and I'm sipping it, right, like this, and there's Drano in it. Now, this is an aggressive example, but there's Drano in it. And I always do this example with my wife poisoning me with my coffee cup, and she doesn't like when I do that, but that's okay. She's upstairs, so she doesn't hear me right now. So anyway, there's that. So if I was sipping Drano, what the Drano would do is it would wear away at my esophagus and wear away at my stomach lining. I would cough out blood. Well, what NOx does in a much slower IV drip type fashion is it slowly wears away at the mechanicals and slowly eats them. And a lot of the challenges we have with especially condensing systems nowadays is when we're venting things, we are not checking the quality of our intake air. Okay. And if you don't have 20.9% oxygen returning back to that system, which is a percentage of oxygen in the air that we breathe, which is a percentage of oxygen your system requires to operate correctly. If you don't have 20.9% oxygen getting pulled in through that fresh air intake, you have the ability to have NOx being pulled out by some other combustion process or some other carbonic acids or whatever it might be that are being pulled back, eating away at the mechanicals down in that system. So that's what it does. So one of the things I think that we're going to have to start to account for is NOx. That's coming down the line, because we're seeing it in California with a lot of low NOx boilers. Denver is now installing low NOx furnaces. We have the fortunate privilege of providing analyzers to the largest contractors in the country. And a lot of them now are ordering it with NOx or low NOx sensors in them, because they have to start accounting for it. And they want to, either they are accounting for it now because they have to, or they want to be ahead of the curve. And I know that it's in California, obviously it's in Denver, and it's working its way this way. So in order to maintain a proper outdoor environment, one of the things that'll have to be done is the accounting for NOx, to make sure that we are not putting those highly efficacious properties out there that are not within a normal range. Once you start testing, you're going to notice that it's in there when you have a NOx sensor in there. So that's one of the things I think is coming. The other thing I think might be coming is the efficiency side of things. As we're going more electric with things, now that might slow down with the next presidency, I don't know. But either way, as we go more electric, I think one of the things we're going to have us start to prove, in order to keep our fuel-fired appliance in play, at least in certain states, would be the efficiency of it. And the only way that we can do that is with an analyzer. The only way you can measure the NOx is with an analyzer. The only way you can measure efficiency with it is with an analyzer. Now, it is combustion efficiency, which is the fuel utilization of that fuel-fired appliance, but it's going to run roughly between 1 and 5% of what the AFUE states the appliance should run at. And you can test this within your own piece of equipment if you have them in your own properties. You can know this for yourself and know that what I'm telling you is actually correct. So I think that those are two things at minimum that we're going to see as we navigate these waters going forward. And, Eric, I don't know where you stand on that, or what your thoughts are on that. Agree, disagree. But I think those are two things that that are potentially coming down the pike. And I've heard rumblings already that some of those things are in the works. So that's where I think some of this is going.
we have had certain programs, especially on the weatherization side of things, where upon installation, they're going out, they're testing this stuff, and they have to show um, a certain specific efficiencies to meet the
Mhm.
program standards.
Mm.
And I forget what the numbers are on some of that. But yeah, there is some of that out there currently, and I could see
Mhm.
where that could expand into different areas just to see what it is
Mhm.
as it's being tested, and we'll have to wait and just kind of have to wait and see. You know,
Yeah.
there's no
Yeah.
way we know for sure.
Yeah.
Um, do you see more manufacturers recommending or requiring combustion analysis at installation, maybe for warranty and things like that?
I've heard that Navion is starting to do it. Cleaver Brooks, Triangle Tube have started to do that. Now, I've also spoken to 5 leading equipment manufacturers where I spoke at a conference, and they pulled me aside when I was done. They said, "What you talked about here resonated with us," and they're all competitors. They're all in the same room together. What can we do to help? I said, "You're going to want to start to put combustion parameters in there. You're jamming these guys up because you're returning things for warranty at an excessive rate, but yet you're giving them no parameters and no instructions on how to use an analyzer. So the way that you've painstakingly manufactured or engineered your equipment to run, we have no clue because you've given us no parameters on what to do." I mean, we can't even get a test board for me to do static pressure in a cabinet. So, I know this is a stretch for you. I say that tongue in cheek, but I don't. I'm saying that in all seriousness too. That's another little bone of contention. But yeah,
We,
I'm starting to see it being mentioned more and more now.
yeah. And just on the static pressure side, we can't even get them to tell us where to drill a hole to test static
Oh
pressure, much
God.
less putting a port in.
Yeah. It's yeah, exactly. And I know that's a pet peeve of Brian Orr's as well. You know,
Oh,
it's
yeah, I'm
it's
right there
and
on that
obviously
train
view
with
of me. Yeah, and that's one of the integral parts of doing all this is getting that static pressure to know where you're at. Um, so those are some of the things I think are coming. And one of the other things I think though, Eric, is so I don't know how many people are in the stream right now. I have no clue. I see some names I've seen before. That it's awesome to see them on here. But one of the things I think is that the people that are on here now and the people that eventually watch this, they're the curve breakers in the industry. When everybody else got a C, you guys are the one, ladies and gentlemen, are the ones that got A's and B pluses. So you're the ones that screwed up the curve. I think we're going to have more people screw up the curve, which is going to help us as an industry. So I think that as you guys, as everybody sees it, you can actually provide for your families and enjoy a manual labor or a blue collar trade and can flourish in it because now you're able to kind of use the greatest technology or some of the greatest technology that is out there in your vocation now, and it's not just used with everybody else's vocation. You can actually use it in yours, meaning our vocation. I think you're going to see more people gravitate to this trade, hopefully, and we'll have better technicians or more technicians. But I think the skill level is rising. We see a lot of people that attend AHR. Eric, we're going to symposium in a month or so, whatever it is, in February. HVAC excellence after that. In Vegas. So there's an increased movement. ESCO in that organization, HVAC excellence, ESCO, they're great at educating the masses as well. You have people carrying the torch like Brian Orr, Craig Migliaccio, all those people, NCI. So I think the educational level is rising. So I think the performance of the industry is rising. So I think going forward, where we weren't as educated 10, 12, 15 years ago, I think that those tables have turned now. Again, by evidence of the people on the chat here and everybody else, that the education's gone up, so the performance will go up, and the testing will increase. And then you take things like MeasureQuick. A tool like MeasureQuick enables somebody to be that much better of a technician, to diagnose, to commission, to maintain something better. You take all these parties kind of pulling on the same side of the rope, it's just an improvement for everybody. That's something else that I think.
good synopsis, I think. That's that was a really good layout. Yeah.
Yeah.
Got a couple other questions here. I'm gonna throw some in. Let's see. We got to that one.
Don't make me think too hard.
What's that?
I said, don't make me think too hard. It's almost past my bedtime.
Oh, I'm going to take this one here. Stefan, so average is a thing. You want it as low as possible. So get it as low as possible. And then look up BPI 1200, look at that specification. There's a table in there that lists all of the CO air free, and that's your high limit. But keep the CO as low as possible in there. It's possible to get some of this stuff reading on the analyzer well below 10 parts per million. I've seen quite a few units out there reading 0 parts per million on the analyzer. Now, some of that can have to do with probe placement in flues, but look up that BPI 1200 document. That's a great document because it lays out all of those limits in that document. I don't want to go through and like read all of those to everybody tonight in the stream. Comment here from Mr. Barbecue Pork. Yes, there are a lot of manuals out there, unfortunately, that don't have those values in them. And we've dealt with that for quite a long time in the industry. Yes, Stefan, for all appliances, all kinds of different appliances in there.
Yes.
There's stoves. Man, I can't even begin to start listing fireplaces, and a lot of them have slightly different values, but all of them are listed in CO air free values.
Yeah. And it's interesting, Eric, one of the things we didn't touch upon tonight is because of time is the CO safety side of things. So, you should all be wearing a personal CO monitor at all times, but you should also have a combustion analyzer because it could save your life and it could save your customer's life. The most common offenders for carbon monoxide in a structure are ovens, stoves, water heaters, and then furnaces and boilers. So you could be there working and you could solve an issue for something you were never sent there to take a look at because of the readings that you're generating either with your personal monitor or with your combustion analyzer. And if you don't think you need one of these in the summer, you are mistaken. You're ever outside working on a condenser and you smell something good because the customer's cooking dinner inside while you're outside sweating like it's the gates of hell? Guess what they're using inside? A fuel-fired appliance. And you're going to go inside to work on the air handler. Have a personal monitor or have a combustion analyzer with you. Even though you're not combustion testing, have one of the two to protect yourself. We like all of you. We care about all of you very much. We want you safe. We want you profitable. And we want you to have as much longevity as you can, as humanly possible in your careers.
Yeah, I want to throw this one up there too. Thanks for mentioning that. Generators. That's another big source, but don't try to stick your normal combustion analyzer in the exhaust of a generator. It's not probably going to go well for your sensor. That's something that you need a different analyzer.
Emissions analyzer.
You need an emissions analyzer for that one. Yeah. And they have a shunt in there and they do all kinds of other math and things like that.
Extra filtration for everything and the water traps, everything.
Yeah. So don't stick your analyzer in like a car exhaust or a lawnmower exhaust or something like that. It's going to be hard on your CO sensor and may actually break your CO sensor. Or poison it to the point that it's not working and you got to send it in to get it replaced or something like that. But there is you mentioned the personal monitors and I kind of wanted to relate this story. And this one came from my dad recently. He was working with some friends in their church and the guy had been at home ill, sick. They ended up moving to a different house because he was so ill and nobody could figure it out. My dad went over there and helping him move, clean the house and get moved out. And he walked back into the laundry room because obviously you put your dryer right next to your natural draft water heater. It's a great place. It's kind of like putting the return on your furnace next to that.
Yeah.
And yeah, he told me, he says, I went in there and he said, I could smell the flue gases, right? That acid in the flue gas coming down. He's like, I knew why. He's like, you told me why. Yeah. Got him out of there. And guess what? The guy feels better now.
Yeah.
It can happen. I've carried a personal monitor for a long time. Thanks to Gary Reeker, not with us anymore, but He taught us a valuable lesson at one of the events we had years ago that Jim Bergman hosted out in Ohio, about carrying a personal monitor. And we found over 200 parts per million in a hotel pool area.
Yeah.
You know, things like that I would never have expected. Now I carry one when I'm traveling. I carry one a lot of places. I carried one as a technician into people's houses. And just like you said,
right here.
Yeah.
Yeah.
Yeah. I got one on it's strapped to my backpack over there. As a matter of fact, I got another one sitting up here on my desk. I got a low level monitor in my house that I keep in there. You know, I've got an all electric house now, but still keep a monitor in there because the worst CO I've ever seen in my own house was actually while we were running an insulation vacuum outside the house. And the wind pushed it right into the house.
Yeah. And you know, it's interesting too, because in the media, only the acute poisonings are broadcast throughout the media. It's not the prolonged, like, slow drip effect of the low levels of carbon monoxide that are reported. And those are the ones where people get sick and are permanently neurologically impaired because they're constantly exposed to it at lower levels on a consistent basis. And the big box store CO monitors are going to go off after they read 30 ppm for 30 days consecutively on their display, a lot of them. And it's, or if they're going to hit highs between 70 and 300 ppm for 1 to 3 hours of exposure.
Yeah, because they're not even going to alarm. They're just going to show that on the display. You got to go up to 70 before they even alarm. Let's see.
And all you get, 9 ppm over 24 and 35 ppm over 8. That's what you get.
Here's another good question we have. This one's a favorite of mine, but I'm going to let you take this one.
How should combustion analyzer be stored in cold weather? Okay. So in a perfect world, and as you see my hairline, that everything is perfect. Even though my ears look like they've been surgically pinned back to my head. I don't know how that happened. But anyway, a combustion analyzer should be brought in when you get below 40 degrees outside, Fahrenheit outside. Now, I know that you're going to all tell me that you're going to do that, but you're going to lie to me. You're not going to lie to me because you don't like me. You're going to lie to me because you're just going to not bring it in because it's more convenient for you when you're out doing your thing. If that is the case, you need to remember something. No matter what analyzer it is, cold weather and sensors do not make very good bedfellows. So if you're going to keep it in your truck, make sure you put it into the cab of your truck. Open up the top of the analyzer case. Don't turn it on because you want to calibrate it in fresh air and auto zero it in fresh air, which is a discussion for another time. Open up the top of the case. So the warmth in the cab of the truck that is warming up your keister is going to slowly warm up and bring up the temperature of your analyzer so that you're not taking a 10-degree analyzer, putting it into a 380-degree stack and calling me saying, I have condensation on my screen, what's up? And I'm going to say, what was your ambient, what was your TA? You're going to say it was 10 degrees. And I'm going to say, what was your stack? You're going to say 370. And I'm going to say to you, do you have any more questions for me? Or do we want to continue this conversation? And you're going to giggle and you're going to hang up the phone on me and say, why did I call that man from New Jersey? That was not right of me. So that's what you're going to do. So there you go.
Let me ask you this. What does it do to the sensors because you get a little bit of moisture in those sensors.
Mm-hmm. Yeah.
What does it do to those sensors if you're storing it in sub-freezing temperatures?
What happens is the media inside the sensors, the expansion and contraction of cold, frigid cold versus testing conditions. It's not conducive to longevity. You can't have that constant back and forth in that because you're going to shorten its life. It's very simple. Are you going to leave your laptop or your, heaven forbid, your cell phone in your truck overnight if it's sub-zero and expect it to function correctly the next morning? The answer is no. This should be treated the exact same way. Okay.
So if you're cold, they're cold. Bring them inside.
That's it. Treat your toys nicely. Stop it. It's Christmas. Treat it nicely. You're not going to get another one.
We got one more question as I'm going down the list here, and then I think we're going to have to kill this because we are over our planned time by a little bit. But this one was too good. I had to throw this out there because I don't think I've ever heard that question before.
Can coffee beans give false alerts? No, but I shouldn't say that. I'm not aware of that, but I have heard of hand sanitizer. back when COVID was in its full regalia. I've heard of certain hand sanitizers causing wacky readings with stuff. I have heard of that. Now, I didn't see it, but I've heard of that on more than one occasion. I don't know if it's all the alcohol in some of them or whatever it is from an off-gassing perspective. I don't know if you're bathing in it, but or lathering up with it, but I've heard that.
I wonder if there's and I think if I'm thinking back on this, and I think I heard something on this once, that the roasting of coffee beans could potentially give some of the off gassing or something while they're
Oh yeah,
roasting, but I don't know about just the coffee beans themselves. But
yeah.
apparently I
It
got to
can
go
do with the
stick a
coffee beans. With yeah,
need to go stick a portable my little personal monitor here in a bag of coffee beans and see what happens.
we did some work at the Nescafe factory that's in New Jersey here, and there were certain rooms you couldn't go into. Some of them, the caffeine was so high, if you didn't go in there with respiration, you would die in a split second. It would stop your heart, and yeah. So there was all kinds of rules and
Wow.
regulations. So it only makes sense that whatever other off gassings just in the general vicinity could pose an issue. It kind of makes sense from a roasting perspective. Yeah.
Yeah, and one of the things we got to keep in mind is pretty much every sensor we have out there has some sort of cross sensitivity to something else.
Yeah.
Like we talked about the CO sensor and the NOx. The
Mhm.
CO sensors have cross sensitivity to other gases as well.
Mhm. Yep.
So, and maybe we see some improvements in that in the future, but I kind of doubt it, because those are pretty well set the way they are. So, anyways, I think we've gone through an hour and a lot of information tonight. Tyler, I really appreciate you coming on. Appreciate
Thank
everybody
you,
out
Eric.
there watching tonight.
Thank you.
We were going to do this for an hour. We're a little bit over that now, but really appreciate everybody tuning in. Hopefully everybody got some kind of good information out of this. Even if you get one little nugget out of it, hopefully it was worth it. And everybody have a Merry Christmas, Happy New Year. Tyler.
Yeah, Merry Christmas. Happy New Year, everybody. Thank you, Eric, and thank you for the team at TruTech Tools for sponsoring this for us tonight. And appreciate you, Eric, and appreciate everybody out there. And I wish the best for everybody and for this holiday season and going forward. And if I can help you in any way as you navigate these waters, I am more than happy to do so. And I am everywhere, all over the country, and hopefully we will be able to meet in person if we haven't yet someday. The rest of you guys out there, and look forward to continuing the conversation.
Yeah, absolutely. You can be found on LinkedIn. Are you on Facebook as well? And
No, just on LinkedIn.
okay,
Yep,
just
LinkedIn.
on LinkedIn. Find you on LinkedIn. You can find me on LinkedIn, Facebook. I'm around at least those two places. I'm on a couple other platforms, but don't spend a lot of time on there. So if y'all need to get a hold of me, find me. Merry
Okay.
Christmas, everybody. We'll see you, and Happy New
Merry
Year,
Christmas.
and we'll see you all in the next one.
You got it.